Hi, and welcome back to the C Beginner to Pro series. In the last few episodes we dealt with conditionals, we studied what Boolean Algebra is, and now applying this knowledge we can start working with more complicated conditional statements as promised earlier. So let's now see the problems from last time. We can see we have a function which returns an integer. It returns 1 if the given input is between 0 and 10, excluding 0 and 10, and returns 0 otherwise. So let's try to make this function right now in our trusty online GDB. So we have returning int between 0 and 10. We take as an input an integer, a right now, and now we need to return 1 if it's between 0 and 10, excluding 0 and 10, and 0 otherwise, which evaluates to true and false equivalently. So let's think about how we can make this. Well, we studied how to make if statements, right? So this is the general structure of our if statement, and then our else block. So in our if statement we want to do when the condition is true. So here's when the condition is true, and here when the condition will evaluate to false. So how to structure the condition? Well, we want to take a to be greater than 0, right? Because we want it to be between 0 and 10, but we exclude 0. And then we want also, so we use the AND operator because we want a to be greater than 0 and a to be less than 10 for us to evaluate the condition as true, right? And in this case we return 1. So we return true essentially. Otherwise, we will return 0. And we can try our function. So let us now see how our function will behave. I've written here a few tests. We want to see what would be the output if we run it with 3, with 1, with a negative number, with the two edge cases, 0 and 10, and then with a really big integer. So let's see what happens. The input does scroll a bit down. So for the first one we get a 1 as intended. Yes, 3 is indeed between 0 and 10. We get 1, and for all of the rest we get zeros as intended. So we can presume that our function works as intended. We can make a more exhaustive test suite, but I think this is sufficient. So let's now take a look at our other function, which is divide by 2 and 6. So this is similar to if you are familiar with FizzBuzz. So it returns 2 if a is divisible by 2, returns 3 if it is divisible by 3, and returns 6 if divisible by both. So let's make this. Divide. First we were returning int, so divide by 2 and 3. We take an input, let's call it in this time, not the general a. And we want to return if in is divisible by 2. If you remember, this is our modulo operator. It gives us the remainder, and when the remainder is 0, we know that in is divisible by 2. Then we have our else block, and in it we can write, so this is evaluated to false, right? In is not divisible by 2, so let's see, is it divisible by 3? If it's, same thing again, remainder equal to 0, and finally, if it's the final else case, is it divisible by 6? Which were the 3 things we wanted to check. And in each of them we can respectively put our desired inputs. We return 6 here, we return 3 here, and we return 2 here. And if it's not for any of these cases, we put else here 0. And so it's not divisible by 2, 3, or 6. Right, so this is a bit of a improper way to structure this. Well, it's not. There's 2 reasons it's improper. First of all, you have this else and then if inside of it. There's a way in C and in most languages to concatenate these things because it makes it more easy to read. So what you can do is simply do else if, as we learned. So like this, and then we can list our cases in a more easy to digest manner. Then our other case, is it divisible by 6? Equal to 0, return 6. Return 6, and In all other cases, so none of these evaluated to true, we return 0. Right, so this was equivalent to what we had written before. However, now it looks a little bit nicer to read instead of this nested if-else structure, especially if you have more conditions. The other one can become hell to read. So this one is, a lot nicer to read. So let's make again a few test cases, right? Let's just replace this, and we can call it straight away with these ones. Let's do 3, let's do 4, right? Let's do -1, a good number. Let's do 12, let's do 0, and then let's do the really big integer again. And let's see what happens. We're missing, we have one extra bracket, so let's see. So 3 divisible by 3, indeed correct. 4 divisible by 2, indeed correct. -1 divisible by none of these, so return 0. 12 divisible by 2 returns 2. However, 12 is also divisible by 3 and by 6, so it should instead be returning 6, right? So remember, if-else statements are evaluated in a sequential manner, so this one, and then if this is not true, then we go to the other one, and then if the other one is not true, then we propagate downwards. So because 6 is a complex number, its factors are 2 and 3. Any number divisible by 6 would also be divisible by both 2 and 3. So always check your more specific cases first and then your more general cases, because numbers divisible by 6 are more specific compared to numbers divisible by 2. So always go from most specific to least specific, or equivalently from least generic to most generic. So what we should instead do is switch our statement a bit. So it goes 6, then returns 6 here, and then whether we check for 3 or 2 doesn't really matter since they're co-prime, so no issues will arise from that. But as I said, go from more generic to less generic. So 3 is slightly more generic, slightly more specific. So go from more specific to less specific. 3 is more specific than 2. Less numbers are divisible by 3 than they are by 2. In the integer case at least. So let's run this again, and we should now see 3 to 0, 6, 0 is divisible by all numbers, so it should return 6 indeed. And then our really large number is apparently divisible by 2 as well. Great, we were able to do this code as well, so let's take a look at the last one, which is both same, which will print the same if both are negative, both are positive, or both are 0, and in all other cases will print not the same. Great, so since we're not returning anything, we are making a void function called both same, where we take two inputs, A and B. And now let's think about what do we do here. Right, so we have three conditions which we want to fulfill, like both are positive, both are 0, and both are negative. In these cases we do something, and in all other cases we do something else. So this again calls for our more complex conditionals. We will this time use the OR statement, right? If you remember, it's naturally as we speak we say this is true, or this is true, or this is true, right? So the way you structure it to yourself linguistically, in natural language, will also kind of hint to you what operators to use. These are simple enough cases that it can be a bit more obvious. With more complicated statements, you might have to think a little bit harder. So let's do this now. We want both of them to be positive. So right, greater than 0, A is greater than 0, and B is greater than 0, or A is less than 0, and B is less than 0. Right, we want both of them to be like that. So and then finally we have them both to be equal to 0. Right, so these are our three conditions in which we want to print the same. Let's put a new line, and then in all other cases we want to print not the same. Because nothing else happens after the else block, we might as well remove this else, right? and do like this. However, here we have to do return, so as to say, okay, continue the code no more after you've printed the same, return from the function, and if this is evaluated to false, we never go inside this if statement here, inside its block, so we print not the same and we return from the function. This structure is equivalent to the one we had right here. It will do the same. You find in programming that there's very often you have two pieces of code that do the exact same function, and since the languages are compiled, you know, they will be optimized to pretty much do the same thing on the hardware level. So it's just a matter of preference how you choose to write it. Write it in such a way that it's most easy to understand by a reader who has no idea what your code is supposed to do. So let's test our code here. Let's see -3 and -2. Let's see, let's say 5 and 100 should also be the same. Our case for 0, 0 as well. And let's do some not the sames as well. Right, let's try -3 and 2. Well, I wrote 1. And then let's try 61, and 0 should also print not the same. We had a missing bracket here because I accidentally removed the else statement. It should be there. Now it is going to work properly. So let's see this. -3 and -2 are indeed the same, both negative. 5 and 100, both positive, the same. 0 and 0, both the same. Not the same, -3 and 1 indeed. And 61 and 0 are both not the same. So this code works as intended. Let's try to rewrite the condition in such a way so that we print the same in the else block and not the same in the if block. So the way you can do this is, you know, put a parenthesis around this whole thing, right? And negate this whole condition. And it's as easy as that. So because we flipped the if else statement, we take the entire condition and we negate it as well, and that way we can flip the if and else blocks, and it still works as intended. Now we can get a little bit more creative in here, and instead of negating this whole large thing, we can make it more concise in such a manner that we say we want this to be like this if a is greater than 0 and b is less than 0, right? And you can write the conditions in this manner. So when it is not the same, and b is greater than 0, and so on and so forth. Right, so here it is written in another manner. All the conditionals have been changed slightly, and it does the same thing as before. So anyways, we saw how to implement more complex if-else statements. We made use of Boolean Algebra, what we learned through it. We utilized if, else statements, else if statements to make better code, to make branching code as intended. In the next video, I'll be dealing with loops. So these are, they utilize conditionals. That's why it was necessary to learn what conditionals are. Because what loops do is they do the same thing over and over again until a condition is met. So I'll see you in the next video. And if you find this series helpful, please leave a like and subscribe. It greatly benefits my channel. Thank you for watching.